Hi, my name is Marissa Hall, and today I'm going to be talking about my Excel report. So let me open it up for you. All right, so here we go. I'm opening up my Module 4 Excel report. This one is building models, and I'm going to start by showing all my formulas for this Excel report. As you see, as we go through here, we've got lots of formulas. Just going to scroll down. You can see where I've put in the formulas here for the millions of people, the percents of millions of people wanting to move out of their countries they were born in. We've got my little scenario here with the shipment of donuts and how many miles it's going to cost to ship those. Coming on down, sneakers, how much you make with the sneakers sold. You can see my formulas there. Okay. This one's the height in feet when launching an object. Here's the number of days for a patron to stay in a resort and how many days they would have with the amount of money. And this last one is the amount of carbon-14 remaining in fossils. You can see all my formulas there. All right, now we're going to take the formulas off and let's go back up here to number 1, start talking about it. So number 1, here we have a worldwide poll from 2008 to 2010. In here, we have taken the 3 major countries with the highest amount of people that want to move. With these numbers, we have conducted that more people wanted to move out of their country than stay. Wow. And out of the 100%, we have 71% that want to move. Out of the 71% that want to move, the 3 highest portions were the United States, Canada, and the United Kingdom. We are only using a sample of these 3 out of the 71%. And so therefore, this does not represent 100% of people because only 71 of that 100 wanted to move, 71%. So this cannot be represented in a pie chart. So we're going to represent it in a bar graph. Here's the bar graph down here to represent the 3 portions. The amount of people that would like to move from the United States was around 34%. You can see here. The amount of people wanting to move from Canada was around 10%, and the amount of people wanting to move from the United Kingdom was also around 10%. All right, moving on down. We're going to go down here to number 2. I've created a beautiful bar graph here, and I've created a scenario. Let's say that we have got donuts. We're shipping them all around the world. We want to create a function. So I've created a function here. And it's going to have the miles it takes and the cost. So you can see where it starts at 0, the cost is going to be at 2 because we still got to pay for those donuts. Whether we're shipping them, where we're shipping them, we still got to pay for the donuts. So the donuts are going to cost us some money. And then when we start shipping them, it's going to go up. So here I've created this scenario and showing that the more miles I drive, the more my cost increases. So for as I continue to travel, I will begin to make a profit because at 9 miles, my cost starts decreasing as I only have to pay $8.75, which is less than $1 a mile. In the beginning, you can see it was going up like $1 a mile. And as I go down, it starts getting less and less, which means I'm starting to make more of a profit. Going on down to number 3, we're looking at the sneakers sold for a sneaker company and the profit on that. At 0 shoes, we're in the hole, negative $240, because we have not sold any shoes yet. We can see that at 4 pairs of shoes, we sold at a point where the company does the worst with a negative profit of $304. And try to move these points. It looks like they've exited the graph a little bit. Okay. All right. And then at the company will break even somewhere between 12 and 13 pairs of shoes. So we concluded that the company has made a profit of $500 by selling 19 pairs of shoes, which is awesome. Must be good sneakers. Going on down to number 4, we have the height of an object in feet in how many seconds, okay? So I've created a chart here showing an initial upward velocity that the maximum height of the ball will reach around 250 or 2,500 feet in 9 seconds. So my chart just kind of shows an upward slope. So I'm going to conclude that if it made that in 9 seconds and it got to its highest point, that in another 9 seconds, which will be 18 seconds, it will hit the ground. And that's my conclusion on that one, because my graph only showed me that much. All right, going on down here to number 5. I went ahead and concluded option 1, option 2, and option 3 for the patron who wants to stay at a resort. As you see, I've made some beautiful graphs over here of each option, and then I've also done a graph with all options to show you the difference here. This is a resort off Costa Rica. With option 1, the patron can stay up to 9 days before the cost equals 0 and they must leave. With option 2, the patron can stay up to 5 days before their time is up. And with option 3, it looks like the patron can stay probably up to around 16 days before they have to leave. So the best option here is going to be option 3 for this patron. On number 6 here, we've got which is really interesting here, finding the percent of carbon-14 left in a fossil to determine how old it is. Wow, that's really interesting. So as we can look here, we've calculated some years, and with our carbon dating formula, we have found that when the fossils that they found had about 37% of carbon-14 left in them, that means that these fossil remains were around 461 years old. Wow, that's amazing. All right, well, that's all for this Excel report. As you can see, I went through and tried to calculate very many interesting things and learned a lot. Thank you.
Okay,